Today we're going to learn to classify triangles, which means to name them, and we're going to look at determining the degrees of a missing angle. So first, when classifying triangles or naming triangles, you can name them based on two different things. You can either name them based on the lengths of their sides. We're going to have a scalene, an isosceles, and an equilateral triangle. Or you can name them or classify them by their angles. So we're going to have an acute, a right, and obtuse. Now we're going to look at each one of these individually. So this is just an overview about what we're going to look at. In our first triangle here, because we have the slashes, I call them slashes, this is indicating that all three sides are the same length. Here's what we know. If all three sides of a triangle are the same length, we know also that all three angles are the same degree. Now, to name it based on all three sides, here's the definition of this particular triangle. All sides and the angles are congruent. Congruent is a word that means the same. So you're going to hear the word congruent a lot. So when we have a triangle with all sides the same length, we call that an equilateral triangle. Now, knowing that it's an equilateral triangle, we know that all the angles are also the same. And we also know that the degrees of all the angles of a triangle equal 180 degrees. So if all of these angles were the same, and there are three angles, and we took 180 degrees and we divided it by 3, we would know that each one of these angles is 60 degrees. 60 degrees there, 60 degrees for this angle, and 60 degrees for this angle. This is just something we know because it is an equilateral triangle. All sides are the same. All angles are the same. The next triangle, we have two sides of the triangle that are same. And because two of the sides are the same, we also know that the two angles down here are also the same. This is the definition of a triangle with two sides and two angles are congruent. This is called an isosceles triangle. Now, when you have a triangle like this, you have to make some assumptions because we know that if two sides are the same, that two angles also have to be the same. So let's say, for example, that this angle up here was 20 degrees. We would know, we would be able to figure out these two angles. Even though there's two angles missing, we know that there's 180 degrees altogether. We know that the top angle is 20 degrees, so how many degrees are left? There's 160 degrees left, divided equally among two angles. So if we take that 160 degrees and we divide it by 2, we would know that each of these angles down here were 80 degrees. So as we look at triangles today and you see an isosceles triangle, they may only give you one of the angles, but you should be able to figure out the other two by figuring out how many degrees are left and dividing it by 2. On this triangle, because there is one slash and then two slashes and three slashes, this is indicating that all three sides are different lengths. If all three sides are different lengths, then all the angles are different measurements. So here's the definitions. No sides or angles are the same. This is called a scalene triangle. We can also name triangles by their angles. Okay, so if you look at this, you'll notice that each of these angles is a different degree. 45 plus 55 plus 80 does equal 180 degrees. But if we look at each angle is different, and all of them are less than 90 degrees. This is what you're looking for. This would be called an acute triangle. Think about 90 degrees. Think about a small puppy dog. Little puppies are cute, so they're less than the size of an adult. So if 90 degrees is the adult dog, these are all less than that, so they're really cute. So we call them a cute triangle. That's not why they're called that, but that's a way to help to remember. All of the degrees are less than 90, so it's an acute triangle. What we also know about this is that means that all three sides are different lengths. So you'd have to have 1 slash, 2 slash, and 3 slashes. If one of the angles is a 90-degree angle, Now down here it does not say 90 degrees, but anytime we draw a little box like this, we are indicating that this is a 90-degree angle. We call this a right triangle. A right triangle is a triangle with one 90-degree angle. Now it is impossible to have two right angles in a triangle because 90 plus 90 would be 180 and you would only have two angles and you couldn't have a third angle and it can't be a triangle with only two angles. So you're only going to have one 90-degree angle. The other one would be, look down here, we have an angle that is larger than 90 degrees, larger than adult. It's a big one. So we call it an obtuse triangle. There will be one angle that's more than 90 degrees. Now, when looking at them, if they don't give you the degrees, like this one is really nice and it says 110 degrees and you don't have to wonder, you'll need to look at it and be able to tell whether it is a 90-degree angle. You can always take a piece of paper because pieces of paper have perfect 90-degree angles and you could lay it on there and see if it's bigger than that. Okay, so we're going to practice naming. As we name these triangles, you're going to name them with two names. One name based on the lengths of the sides and one name based on the angles. So look up here. First of all, look at the sides. All three sides are different. So we know that that is a scaling. And based on the angles, we see one 90-degree angle. So we know it is a right scaling triangle. Okay, so you try it. Now look at this one. Look at the angles first. Do you see any that are exactly 90 degrees or more than 90 degrees? Look at the lengths of the sides. What do you think you would name this triangle? This is an obtuse because this angle right here is greater than 90 degrees. And we know that there are two sides the same, so we call that an isosceles. So this is called an obtuse isosceles triangle. Okay, first look at the angle. Do you see any 90-degree angles? Do you see any angles that are greater than 90 degrees? Based on the lengths of the sides, can you come up with the two names? This is an acute because all angles are less than 90. And it's scaling because none of them have the same length. An acute scaling triangle. Okay, look at the angles. None of them are greater than 90. So that's going to be acute. You have two sides the same, so that's going to be isosceles. So we call it an acute isosceles triangle. I'm letting you look at this triangle for a moment. At the top, you will notice an angle that is greater than 90 degrees, so that would make it obtuse. None of the lengths are the same size, so that would be scaling. So it is an obtuse scaling triangle. Right here, the square tells you something. It tells you that it's an exactly 90-degree angle, so we know that's a right triangle. We know that two sides are the same length, so that is isosceles, a right isosceles triangle. Okay, now, knowing how to name them and these particular properties of triangles, we should be able to figure out the missing angle. Remember that the sum of all triangles, of all the angles, is always going to be 180 degrees. So if you look at this triangle, you're actually given two angles. This one does not give you a number, but it gives you the symbol to let you know that this is a right angle. So we know this one's 90 degrees, even though it doesn't say 90. We know this angle up here is 70. So if we add 90 plus 70, that gives us 160 degrees. And if we subtract that from the 180, we can figure out the missing angle, which would be 20 degrees. Okay, look at this triangle again. Here you have a 90. Here you have a 35. Now, if you like a shortcut, if you know one of them is 90, you know there's 90 degrees left because 90 and 90 is 180. So I could just take 90 degrees and subtract 35. Or if you want to do it the longer way, you can go 90 plus 35 and get your answer and then subtract it from 180. Either way, you're going to get the same answer, which is 55 degrees. This is an isosceles triangle. It gives you that these two down here are both 70. 70 plus 70 is 140. So what would the missing angle be? 180 minus 140 is 40 degrees. So you're going to use these properties to help you with your assignment today. Okay, I've pulled up one of your assignments here. On the first part, they ask you to classify. That means to name it with two names, one name based on the angle, one name based on the length of the sides. So let's just try the first one. If you look here, none of these are greater than 90 degrees, so we know that's an acute. And if you look at the lengths of the sides, we have 8, 9, and 9. 9 are the same, so two sides are the same, so that would be an acute isosceles. You can do that with the top part. You're just going to look at the names of each one of them. On the bottom part is where you have to find the missing degrees. For example, let's look here at number, whoops, come back up there. Let's look here at number 10. We know that this triangle has 180 degrees. If you look right here, we know it's an isosceles triangle. That means these two sides are the same, which means these two angles are the same. You're only given one angle, but we know that these two are the same. So if we take 180 degrees and we subtract the 106 degrees to find out how many degrees would be left, that would be 74 degrees left divided equally among 2. So we just take the 74 degrees and we divide it by 2 to get our answer. There's several in here that are similar like that. Number 12 right here, they give you none of the numbers, but they do tell you right here the symbol. So you know this is a 90 degree. If this is 90 degrees, there's 90 degrees left. And look, it's an isosceles triangle, which means these two sides and these two angles are the same. If it's 90 degrees here, there's 90 degrees left divided equally among 2. So you just take 90 and divide by 2. So you can use that to help you with this side. On the other assignment that you're given today, again, you're going to practice classifying. Here it says just to classify it based on the angle. And so it gives you 3 letters, and you have to find that angle. For example, angle AHB. So you think AHB. Okay, so they're talking about this angle, 20 degrees. Well, that is an acute, so you write acute because it's less than 90 degrees. Let's look at number 6, angle AHG. AHG happens to be this angle, which happens to be a straight line. We didn't talk about that, but hopefully you recognize a straight line when you see it. So I just say straight. On the next part, again, you're going to be looking for missing angles. And it does not want to roll for me. So we'll just go over here. Again, let's look at number 8. You're given this angle. We know this one is 90. We know this one is 45. And if one of them is 90, you know these two together are going to be, look right here, isosceles triangle. You know both of these are going to be the same. So if this one is 45, you know this missing one has to be 45 degrees. Notice the directions. Find the value of x and then classify each triangle by its angles and by its sides. So the missing angle was 45 degrees. It is a right. It has a right angle. So this is a right. And two sides are the same, so it'd be isosceles. So hopefully that will help you with your assignment today in working on classifying, which is naming triangles and finding the missing angle.